Take it away? Okay. Thanks everyone for connecting. My name is Alanna MacNevin. I'm going to do a little bit of a intro during the presentation, so I won't get too much into who I am, but I'm going to give a little bit of a basic intro to gRPC. But first, whenever I give a presentation, I always like to give certain acknowledgements, and I have 3 to give tonight. One is that to acknowledge that we here in Nova Scotia are all on unceded Mi'kmaq territory, and that's important to remember right now because one of the key things to combating COVID-19 is to wash your hands and stay away from people, which a lot of people, which a lot of communities can't do and don't have access to. And I apologize also, my dog, my coworker is going to interrupt this. I was hoping he'd sleep through it. That's the first acknowledgement. The second one is just like kudos to all of our frontline workers, including healthcare workers and also the people who are doing cashiers. And we mentioned Amazon, like all the people who are delivering our packages and things like that. Like they really make shit run. And then 3 is all of you and all the organizers and volunteers. And Gab, that was an awesome presentation, so thank you so much. I really enjoyed that. That is my dog. Who am I? So my name is Alanna MacNevin. I have been a software developer for about for a few years now. Since about 2013, I moved to Lima, Peru. I moved to Lima, Peru to, he was quiet during all of, I don't know if anybody can hear him, but he was quiet during Gab's presentation the whole time. So I moved to Lima to be a Drupal developer, front-end developer as well, with an NGO in Lima. And so slowly have been learning more and more and more, got away from Drupal as soon as I could. And right now, I'm working as a React developer, front-end developer in React and Electron, and I'm the project manager for the projects that we're working on at Talkatoo. And a bit about Talkatoo is we are a, I always stumble on this. Basically, we provide speech-to-text transcriptions geared towards veterinarians and hopefully other medical professionals in the coming year. And I really love the team I work with and the technologies that we're working on. And so since I too am only a front-end developer, I told Gab I'd pick on her for that, is that I wanted to use this as an opportunity to learn some of the back-end stack that we use that I wasn't super familiar with. So we use gRPC to do bidirectional streaming of audio to our backend and then sending transcriptions back to the user. So I'll get a bit more into that a little bit. And then one more final aside before I really get into the meat of this presentation is that when I first was approached to present, some ideas thrown around of like what I could present on were kind of like, oh, you could present on your journey from being a front-end developer to being like a team manager or team lead. And I don't really know what I'm doing as a team manager right now, and just sort of like every day is new. But one of the key things that I learned from a project manager that I hold near and dear to my heart, not only because she's my sister, but it's because she's awesome, is that she assured me that it's totally fine and actually better if you are not the smartest person in the room. And that the best thing to be able to do is to ask questions and be okay with asking questions and be okay with putting yourself out there so that you can kind of figure out what's going on. So I wanted to encourage all of you to, if I get something wrong or something isn't clear, to like pipe up, or if you want to know something more about, if you want to know something more about a particular thing, or if you want to like add to a certain piece, that's totally encouraged because we're all here to learn. Okay. Here's what you're all here for. This is the outline of the presentation. So basically, I'm going to get a little bit into what is gRPC, and then I'm going to review the basic concepts of RPC, and when and why you would maybe want to use RPC. And then there's this sort of idea of like RPC versus REST. And then get into a bit of gRPC and protocol buffers. That's one of the main concepts within that belongs to gRPC. And then a bit of a conclusion and discussion. And we'll see, this is the first time doing a virtual meetup, so we can kind of see how a discussion can be formed around like using a conduit. So quickly, I'm going to get into more details of what gRPC is, but quickly, if you're not familiar with what gRPC is, it's a recursive definition, which I love these. They're always fun. So gRPC stands for gRPC, Remote Procedural Calls. It was created by Google, and it's a high performance, standards-based, open source, general purpose, feature-rich remote procedural call. Basically, you define a set of method calls using a custom language, which just means like any language. And then each method call has a single message and as its request, and then a single message as its response. So it's like, for in case that's a new concept for you, that's what gRPC is. RPC, I'm sorry, I'm going over the place. RPC is like an older concept. So gRPC is relatively new. RPC is an old concept, and it's just a client-server interaction. It's you're asking a remote server to do something, and then it gives you something in response. So I just put some, you send a request that I want some cookies. Can you mail them? And you send them to your mom because you can't leave your house. So basically, it's the same as like client. You're sending a certain number of parameters to a server, and then you get a response. If she loves you, she'll send them, and if she's tired of your business, she won't send them. So let's go down here. I am reading off notes, so I will, let me just slow down and take. So again, the RPC allows a client to make a procedural call or a procedural call is also a subroutine call or a function call to a server on a different address space without understanding the network configuration, as if the server was in the same network or as if it was a local procedural call. And that's sort of like the draw of that. So basically, you're executing some kind of method by name on another computer. It functions like a normal method call, accepting a set of parameters that are serialized over the network and a response that is serialized over the network. And there are actually a lot of frameworks for RPCs, and gRPC is just one of them that we're going over today. So how RPC works. It's a little diagram, and I'm gonna read over some points and like, so first you have a client application is making a local procedural call to the client stub containing the parameters to be passed on to the server. The client stub serializes the parameters through a process called marshalling forwards, and the request to the local client time library in the local computer, which forwards the request to the server stub. The server runtime library receives the request and calls the server stub procedure, which unmarshals, just unpacks the past parameters and calls the actual procedure. And the server stub sends back a response to the client stub in the same fashion, at which the client resumes normal execution. It's just, you're all familiar with this sort of things. So why and when you should use, I put user RPC, that's okay. You should use RPC. You can use it, it can be used in most cases. So you can use it for like to build distributed applications. You can use it to access resources on GCP. But its main draw is that it's ideal for building out scalable microservices architecture. And that's because it uses a data serialization, which I'll get into a little bit more. And it just, that data serialization just improves performance in comparison to reading JSON or XML formatted information. Let's see. So RPC versus REST. And I'm assuming, this is me making the assumption that everyone's familiar with REST and maybe aren't familiar with RPC, but you might be familiar with both. So both RPC and REST use request response HTTP protocol to send and receive data respectively. RESTful systems view HTTP endpoints that can be distributed across different services as resources that have an associated set of standardized verbs. So basically, REST is sort of confined to the get, put, post, delete that can be invoked and interact with that resource. RPC implements client and server stubs that essentially make it possible to make calls to procedures over a network address as if the procedure was local, which is to say that the RPC exposes methods in the server to the client. But benefits of RPC is that it uses HTTP2 and it has lower latency. And while both REST and gRPC and RPC can generate client server stubs, as I mentioned, REST has a limit on the primary functions. So that's the create, the get, put, post, delete, or create, update, read, update, delete. Whereas gPC, you can define any kind of function calls, including synchronous, asynchronous, and unidirectional and bidirectional. And as I mentioned, we chose gRPC for one of our, to handle one of our functionalities because for the bidirectional feature that we had access to. And so while RPC is great, it's actually, it's not productive to compare one versus the other because they actually really work well together, and we're using both in ours. RPC and gRPC are really just great for building microservices. So a little bit more, if we go into depth about gRPC. So this is a Google managed, so gRPC is Google managed, and it's very popular, and it open source, as I mentioned, RPC framework that has the support of many languages. One of the biggest draws is that it's language agnostic. With gRPC, a client application can directly call methods on a server application on different networks as if the method was local. And the beauty of that is that it's, again, as I've just mentioned, it's language agnostic. This means you could have a gRPC server within a Java client handling calls from any other language, Node.js, PHP, Go, whatever. gRPC allows you to define a service which specifies the methods that you can call remotely. You can call remotely, and the parameters that can be passed to the procedure call, and then return the response. The server then implements this definitions and creates a new gRPC server to handle the procedure calls from the client. And to do this, by default, gRPC uses protocol buffers. It's not the only way to do it, but it's not, protocol buffers aren't required, but it's one of the highlights of it, and it uses these protocol buffers to serialize structured data, as well as define parameters and return responses for callable methods. That's more of the benefits. So as I mentioned, this is sort of like bullet points. gRPC is built HTTP2. Serialization of data is way faster and has better performance. Protocol buffers make it easy to define services and generate client libraries. And I'm going to go more into protocol buffers in a moment. It's language agnostic, which is, I'll also get into a bit more, which is really cool. And it's built to be available on any platform, and it's strongly typed, which is also a great benefit. So protocol buffers. Protocol buffers are Google's language neutral, platform neutral, extendable mechanism for serializing structured data. So it's often compared to XML, but faster, smaller, simpler. some of the benefits I have listed here. So I mentioned language neutral, platform neutral. Parsing binary data is way less, costs way less to do that. Its structures can be extended and maintained with backwards compatibility. It's a code generation, so like it will help you generate code that you don't actually want to write, and that it's strongly typed helps to prevent conflicts. And this is more of the same. So with protocol buffers, it's easy to write message. It's easy to write message definitions, and so it's actually makes it really easy to write your services. The definition of the API is separate from the implementation, so you can get started right away. And as I mentioned, a huge amount of code that you might not want to write gets generated by these proto files, which I'll show you a little bit of. With the passing of serialized data, it's the performance is improved significantly because you're sending binary data, getting it, and the deserialization, serialization of it is faster. So here's a little preview of a protocol of what a object in a buffer would look like. And before I get into the actual files, I will talk a bit more about what it means when we say that it's language agnostic. So, so again, great things about this is the code is automatically generated, and which it means that any microservices written in any language can interact with each other. So scenario that this would happen in is maybe you have a website that has a purchase service, and let's say that your team has written that in Go, and then you have another team that has a pricing service and they're data scientists and they've written it in Python. And then you have your mobile app, and your mobile app is written in Java. And I know that's not what's really written on this diagram, but just replace the Ruby client for a Go client and the C++ for whatever. It's really just cut and paste. And how are all these going to talk to each other? So it's actually really simple because both of the services that were created using gRPC, you can generate a stub or a client on the mobile app that will automatically so the stub will automatically have implemented all the calls to the services using the protocol buffers and gRPC for the requests and response that you're going to get back. So I had hoped to get into all of the steps to create a sample application for using gRPC, but we are Taco 2 kind of handling a few extra load considering the changing times. And so I only got into, I'll just get into the first, which is just sort of talking about how you define the protocol buffer messages types, and a little bit about the services using the language guide, the language guide that they have. So I'm actually going to pull up. I don't know how to change. I'm not sure how to change a screen. Show a file that I did not include in my screen. Stop. Let's move this over. Let's share. And so yeah, you can see that. So I was going to show you our own code, but I decided not to. But in our Electron app, we are using this to make several calls for just taking in audio, sending it to our backend, and then sending back transcriptions of that audio. But this is an example of a protofile that I found on the internet. And basically, I'm going to break it down for you so you can see how sort of, so the key parts of writing a file. And then what happens would be is that you would compile this, and that's the generation of the auto-generated code is the part that I was mentioning. That is the code that you don't want to have to write. So you write the protofile, and then generator from that is the other files. So the first part of this is basically you define the protocol buffer language syntax. The latest version is like 3.11 something, but which means that you're using Proto 3, and it's just the most up to date. Next, which is optional, is you give a unique package name. And this just prevents, giving a unique name just means that you can prevent clashes between protocol messages, as I understand. Then you are to define the interface that stipulates what parameters each method in the gRPC server takes and returns. So in this case, we have a service that, this service that I found was just like an example of employees asking for leave and then getting a response for that request. So each, so as I said at the beginning, each request has a message and each response has a message type. And each message type has fields and then is serialized. And the serialization is just the part where it's breaking it down to reconstruct it later. Yeah, so we have here just each message has a name value field pairing in the field. That is an example of a field. I can come back to any questions that might come from that. Now, how do I find my slides again? I lost my slides. Well, that's okay. Oh no, they should be there. That's okay. You know what I'm going to do? I lost my slides. I don't know where they are. I have like a million tabs open right now. I'm just going to stop sharing because the last part of my presentation is just talking about the types of now I will share the types of service, the kinds of service methods that you can create, which is all located on the gRPC website. I cannot find it. No, I found it. So I mentioned that we are using bidirectional streaming, but that's not the only service method that you can define. There are four. You have unary RPC service methods where the client is going to send a request and the server is going to send a response. Client streaming RPC, the client sends multiple messages and then the server sends a response. And server streaming RPC, client sends one message and service sends multiple messages. And bidirectional streaming, where the client and server can independently send multiple messages to each other. And as I mentioned, we're using bidirectional streaming to stream audio and send transcriptions back to our application. And these two streams operate independently, so clients and servers can read and write in whatever order they like. For example, the server could wait to receive all the client messages before writing its responses, or it could alternately read a message, then write a message, or some other combination of reads and writes. One of the things that we're waiting for is, for ourselves, is this bidirectional streaming is not supported in browsers yet, which means that we have some lag in our application, in our web application. The differs from our desktop application. Sorry about losing my notes there. So in conclusion, so now I don't actually need notes. My ending slide was just going to be as I was preparing for this presentation, I knew that I was like coming into this, into gRPC as more of a learner than a presenter. But I wanted to kind of hear from the group what their experiences were using gRPC, and if anyone had any questions, and I can like talk more about our actual use of gRPC as well, and use of other use of it in combination with our technologies better as well. Like kind of I'm better at off the cuff conversations anyways, or questions anyway. Can't hear anything, so I don't.
So there's a couple of questions coming out of the chat that I can kind of feed over to start. The first question was around whether or not you have any experience benchmarking REST versus gRPC and sort of the speed or performance improvements that come with that.
We haven't in relation to, I've only used it in, sorry, I should be playing on my screen while I'm talking to you. I was just trying to open a window. We haven't benchmarked RPC and gRPC and REST. We chose it because it has functionality that we needed that REST doesn't provide. From what I've read, based on like how it intakes and sends out data, it is stated as being faster. I would have to, I mean, always like someone can state something and the actuality can be different. So we haven't benchmarked it for our use cases because we're only using it right now for streaming. In our web app, I mentioned there's like a difference. So in our web app, we're actually streaming audio through WebSockets, and then in our desktop application, we're streaming it through we're streaming it with gRPC.
And then do you have, as follow-up was, do you have any sense of what kind of additional use cases for gRPC besides the bidirectional streaming that you're doing?
Yeah, so it's actually really set up well for building microservices. So if you're not familiar with like microservice infrastructure, my example that I tried to describe with the different teams having built different services in different languages, that's sort of the idea. And the idea with using the reason that gRPC or or probably any other gRPC or RPC framework is set up to work well in those situations, is that you don't have to worry too much about how one service is going to talk to the other, because they can all talk to each other using the same, you just need to build the proto file. So you end up having like a simpler implementation, and your teams can work like outside of each other, and you don't have to worry about one service or one client like messing up. Like development isn't ever going to really affect the other services, is the benefit, from what I understand.
Great. From the webinar, how does authentication work in gRPC? In REST, you can include an authorization header with an API key. Does gRPC have something similar?
I saw that question, and the reason I was distracted is because I was trying to look through our code, because I actually don't remember the actual answer to this, but we do authenticate. I just forget exactly how. It's not in a header. It's yeah, no, we do send, you can send, we send, whenever we're creating our transcription client, we end up sending the endpoint and credentials. I can get back to them of exactly how we're doing that. Actually, it's one of those things where you know the code, but you can't remember what actually has been written. So I can get back to more exactly how we're dealing with authentication, but there are ways to send credentials and create secure connections over SSL and things like that.
Okay, so that one came from Brandon Node. If you'd like to follow up with them.
Yeah. Yeah.
Continuing down through the chat, how much overhead in regards to time is developing using gRPC over regular REST, have you found?
Well, so as I mentioned, I didn't develop I read the code that was developed and understand it, but did not, and like it was playing and more catch up on what was happening. Returns to REST, we chose it because we assumed like it's because you can write just the simple proto files and just define your messages and then have the other code generated. It actually is going to improve development time. I haven't done any benchmarking. I can't say. I really, as a front-end developer, I really like working with proto files and it's easy to read them. Similar to REST, it has Swagger documentation that's easy to read, but I find even just the proto files themselves are easy to read. If I want to go in and see how something works, I can easily understand it. So, I mean, all in all, I think that if we could, since our web app isn't, I think maybe one way of answering that is, if we could have more things rely on gRPC, we would, because it's more pleasing to work with. I think we haven't benchmarked our development time, but I think it is an improvement in development time, and I think the whole team enjoys working with it because it's easy to understand, easy to write, and preferred not to have WebSockets over here, gRPC over here kind of situation, but that's where we're at.
Great. Next up from, I believe Joe Moore has 2 questions here. Have you had to change your message structures? If so, how did you roll out the changes? And how did you share protofiles between services?
Sharing protofiles between services. So one, for changing the message structure, we've added fields, but we try to avoid adding fields that we don't want to maintain for later. We've only had our code live for maybe a year right now, and so we haven't run into huge issues with that. So not a great answer to your question, but I think the idea behind the messages is that just keep them simple, which is why we're trying to avoid, you have a request come in, of just like adding a field without thinking about it being maintained.
And then the follow-up question, along the lines of, when evolving a profile, what's the process for upgrading clients and servers?
Actually, I am maybe lying to you. We have upgraded our servers. So we have different, basically we just do, again, I'm not the person who writes this, but I know mostly how the processes work. We do actually have different versions of our messaging structure and of our API in the back end. And we just base it on versions, but different versions. But with gRPC, it does support, for the most part, backwards compatibility. So you can evolve things without too many complications. I'm trying to remember anecdotally what our big version jump was. But I am not going to recall that. And we don't share proto files between, what was the other question about?
Upgrading the clients and servers, and it was sharing between services or rolling out changes to message structures was the earlier question.
Right. That is a good question. I don't know if I can really get back to that. I think I would have to go look at our lab to figure it out.
So then for Matt Johnston, is gRPC well suited for public APIs? It doesn't sound like you're using them for public APIs, but if you have any perspective on whether it still just makes sense to have REST or GraphQL in front of things external developers are consuming.
I mean, I think you can. I think from what I was reading, you can. It's just like when and why you would want to use it, and it's better suited. It's well suited for like server-to-server interactions, for microservice, like for building microservices, and but it doesn't preclude that it can't be used in those other cases at all.
Great. Ian Livingston asks, are you using the gRPC gateway to work with gRPC on the front end?
I can't recall, Ian, I'm sorry.
Moving along then.
Oh for 8 right now.
Moving on to Sandy's question, how does error/exception handling work across the wire?
Oh yeah, so that I can kind of answer. You would get there's like, from my experience, actually, why don't I show you? It might be interesting I can show you maybe a bit of stuff too. I don't know if that's maybe interesting, but error handling, basically, if you have a stream that's open, you're just going to get a message back, and you can choose what to do with it. So if you get, there's different error types that are listed. You can go look them up, but you're going to get examples would be like, okay, just means like everything's fine, canceled, the stream is canceled, and then there's all sorts of other kind of unavailable type things are going to come back to you when you're streaming, whenever you're connected. And whenever you receive a message, you can choose what you want to do to the front end client. So it's like, for us, in our case, to give you a better example, I guess, of what I'm talking about is if we get back, we listen for silence, and we listen for, like, you can put different, I apologize, my dog is harassing me. You can put different, I forget what they're called, but kind of parameters on like how long you want to listen, or how long you want to listen for a response. And if that is exceeded, you'll get back a message that says like, I don't know what's going on, and then you can just shut down you can communicate to your user on the front end. But so it operates the same way as receiving an error. Maybe it would have been interesting to go through them, but it's yeah.
And last question from Chris Adams. You mentioned Web Audio API. Are you streaming real-time audio data using gRPC, or are you splitting that up into files?
We are we're not splitting it up into files. If I can remember correctly, we are encoding it as FLAC. We're using the Web Audio API. They're called I'm not going to remember, but yeah, we're not sending it as files. We're streaming it as just streaming data and encoding it ahead of time so that it reduces the the resource use.